Hello everyone, welcome to today's class. This is Teacher Simon taking you through AS Pure Mathematics 1 paper 9709/12 for May, June 2021, and this is part 1 for questions 1 to 6. Question 1 part A, they're saying express this one in this format here. So we are going to use two methods here. Pick the one that is simpler for you, okay? But this is what we call completing what? Squares. So I can use direct completing of squares and also expanding brackets, and then we equate what? Coefficients. So let's begin with the direct completing of squares. So minus 24 of x, then plus 10. Now here the coefficient of x squared is 16. It's not a 1, so we first factorize it. I'll put it outside, then I have x squared, then minus 20. Now when I put 16 outside, that means here I will divide it. So negative 24 divided by 16, we shall get what? By 8, 3 by 8, 2. So this one will be negative 3 over 2. So inside here, I'll put negative 3 over 2 of x. Then I will leave this 10 outside here. So plus 10. Okay. Then after that, we are going to look at this part here that has gotten x's. So suppose I have x minus b, then squared. To expand this one, it will be x squared minus 2bx, then plus b squared. And then I want only this part that has gotten the x's. So I can take this one, this sign, and then we have x minus b, then squared, then minus b squared, which is going to be equal to x squared minus 2bx. And then right from here, you can see that the coefficient of x here, which is minus 2b, it was divided by 2, okay? Then it was put here and also here. So that means when I come to this one here, I'm going to do the same. So I'll have, get the coefficient of x here, which is negative 3 over 2. Then you divide it by 2. This one is 2 over 1. So this is the same as saying negative 3 over 2, then times the reciprocal of the denominator. So this one becomes negative 3 over 4, right? So if it is negative 3 over 4, then we shall write here x, then, let me first take away this. So it will be x, then minus 3 over 4, then squared, then pop this one out as a square. So minus 3 over 4, then squared. You see that? Then there is a 10 here. So whatever is in here is this, okay? So just like we did here, after dividing this by 2, then you put it together with the x in brackets and the square, then you pop this b out, and then you square it there, okay? So that is that. Now the rest is to simplify. But then looking at what is here, the coefficient of x here is a 4. So that means I'm going to get one fraction here. So you also multiply the 16 all through. So we shall have 16, then times. Here we can have, if this one is over 1, then the LCM here is 4. Divide by 1, you get 4. Then times x. So we shall get 4x. Not so? And then 4 divided by 4, you get a 1. Then times this negative 3. Then we shall get a minus 3 there. Then squared. And then this 16 is also supposed to multiply with whatever is here. So we have minus, this will be 9 over 16 when we square the 3 over 4. Then times the 16 that is coming from out, okay? Then we shall add on the 10. And then right from here, we can have the 16. Then this one is 4x minus 3 squared. Then you also square this denominator. It will become 16, not so? This one will also go with that. And then when this one goes, we shall have 10 minus 9, that's a plus 1, not so? So here we shall have a plus 1. So meaning now everything all together is going to become, you can see that this one can cancel with that. So our answer then becomes 4x minus 3 squared, then plus 1. That is that. Alternatively, expanding brackets and then we equate coefficients, what are we going to have? So we have this 16 x squared minus 24 plus 10, which is the same as this 4x here, then plus a squared, then plus b. We then expand the brackets here. So what do we get? Square this one here, you will get 16x squared, then 2 times this times a. Won't that be 8a, then x, and then square the a, you'll get a squared, then plus the b. Now the coefficient of x squared here is 16, and also here it is 16. Then you go to the coefficient of x, it is negative 24, and then here it is 8a. So that means I will say negative 24 is equal to 8a. Then when we divide all through by 8, this simply implies that our a then shall be equal to negative what? 3. Okay, now do you see that here we are having negative 3? The next we got to be the constant part. We are having here 10, then is equal to, this is the constant part, the part that doesn't have the what? The x, independent of the x. So we are going to have a squared, and that is minus 3 squared, then plus the b. So this will be 10 minus, of course, even power of a negative is a positive, but then when it crosses, it becomes a negative. So it will be minus 9. And then our b becomes a positive what? 1. Now, we can write this one again here. Let me just put it here. Therefore, wherever there is a, I'm just going to put a minus 3, and then where there is b, I put a positive 1. So put minus 3 here, and then a positive 1 here. So this is our answer here. So you can see that what we are having here is the same as what is there. So choose a method that is simpler for you. Then next, the part B, they are saying it is given that this equation here is equal to k, where k is a constant, has exactly one root. Find the value of this root. Now for one root, this simply implies that you have something like this. Maybe we have ax, then let's say plus b squared is equal to 0. You see? For the repeated root, such that you get this x, which is going to be, let's say, negative b over a. Okay? So how do we then get this one out of what is given? Now we can see that we have, actually even this one I can do it in 2 ways. Okay? You also choose the method that is simpler for you. Okay? Now we can have, this one is 16x squared minus 24x, then plus 10, which is equal to k. Now this one we have seen from up there, it is 4x minus 3 squared, then plus 1, then is equal to this k. Okay, now I can bring this k here, and then we have 4x minus 3 squared, then plus 1 minus k is equal to 0. Remember, I'm looking for something squared which is equal to 0. Okay, so for one root, or that repeated root, then k has to be equal to 1, such that this one goes to a 0. You see that? So if k is equal to 1, this simply implies that our 4x minus 3 squared will be equal to 0. And then take the square root of 0, of course that one is 0, then x is going to be equal to 3 over 4. That is that. You see, that's the value of that. Or alternatively, you can do this. We can have, if let's say we have a quadratic equation given by ax squared plus bx plus c is equal to 0. Okay, let me repeat this, and I say for ax squared plus bx plus c is equal to 0, we know that x has to be equal to minus b plus or minus to the root of b squared minus 4ac out of what? 2a. Not so? Then this discriminant here in the square root is the one that determines the what? The nature of the root. Okay, so for a repeated root, what do we know for a repeated root? The b squared minus 4ac has to be equal to what? To 0. You see that? So this simply implies that the repeated root is going to be equal to minus b out of 2a. This one goes because it is 0. So what remains is this minus b out of 2a. Now, here we shall get our answer as our b is going to be this negative 24. So negative of negative 24, then divide by 2 times our a is this 16 here. 16. And this one is going to be positive 24 out of 32. Also, then divide through by 8 and also down here by 8. So don't you think the answer is 3/4? So that is that. You see that it is the same answer we get here. So the repeated root of a quadratic equation is always given by minus b out of what? 2a. And it is also the line of symmetry of that graph, which actually happens to be the x-coordinate of the turning point here. Okay, here. So that is that. Question 2 is coming from transformations of functions. Part A, the graph of y is equal to f of x is transformed to the graph of y is equal to 2 of f into x minus 1. Describe fully the two single transformations which have been combined to give the resulting transformation. Now, let me take you to something here. I said that in many of my videos, I've always said that if you see a subtraction or an addition on the x or y, then that is a translation. If you see a multiplication on the function or on x, that is a stretch. And then the change of sign of y or x becomes the reflection, okay, in either x-axis or y-axis. Now, if I come to this graph here and then I say that, let's say we are having y, which is equal to, let me use x squared, okay? This will be the graph here, okay? And then we say y is equal to, let's say inside here we put 2x. So instead of the x, now I write 2x, okay? In fact, let me not use this one here because I'm seeing there is x minus 1, okay? So when I come to this one here, I'll just put x, then minus 1. So let's put minus 1. You see that I've put a minus inside here, okay? But I have gotten my graph shifting to the right by 1 unit. So if this one has shifted by 1 unit to the right, that is what we call translation by vector 1, 0. So meaning the number that comes out of here. So when we go to write the translation, it changes the sign. So if it was a negative here, then it comes here as a positive. You see that? So that means when I come back here for y, which is equal to f of x, now y is equal to f of x minus 1. This is a translation. This is a translation by vector 1, 0. You see that? Then next we have y, which is equal to 2 times this. Now we are multiplying a function by something, so that one becomes a stretch, okay? This is a stretch by factor 2, of course, then parallel to y-axis. And these are the two transformations that we need. This one here and this one here. Let me also show you this one. When it comes to stretch, So suppose I get this graph of mine here. Let me remove this, and then I put 2, then x squared. So for the same x coordinate here, which is 1, okay, then the y coordinate of this one is what? Is a 2. Here, the y coordinate was a 1. So do you see? You just multiply the y coordinates by that scale factor, that stretch factor. You see that? So that is that. It's just stretch by factor 2 parallel to y-axis. X has not changed, okay? So it is what we call the vertical stretch, and that is that. Then part B, they are saying that the curve y is equal to sine 2x minus 5x is reflected in y-axis and then stretched by that factor 1 over 3 in the x direction. Write down the equation of the transformed curve. Now we look at this one reflected in y-axis. So if you have this one here, let's say these are our axes here, okay? Let me first draw axes here, and then you have this one is our x-axis, this one is our y-axis, and then I have a point here, x, y. We are reflecting in y-axis, right? So let this one be in a mirror line. The image is going to be on the opposite side. So suppose it is here, then the x coordinate is going to be a negative, and then the y coordinate remains, not so? So that means if we have y, which is equal to f of x, okay, then for reflection in y-axis, okay, then y has to be equal to f x has changed the what? The sign. You see that? And I told you that if you see the change in the sign, that will be a reflection. So what are we now going to have? Y is equal to, wherever there is x, I'm going to put a negative. So sine of now 2, then x, you put it as a negative, then minus 5, and then negative x. You see that? And sine of a negative angle is the same as negative sine of that angle. Sine of negative theta is equal to, in trigonometry, is the same as negative sine of that angle. So meaning I can write this one as this one becomes a positive, right? And we are having 5x, then the whole thing here is a negative, so it will be minus, then sine of 2x. You see that? What else do we have? When we go back to this diagram here, and we stretch this one in the x, okay? So let's put a 2 here, and then I'll close the brackets here. So I've put a 2 here on the x, but you see that the graph diminishes. You see that? So implying that for the same y coordinate here, which is a 1, the x coordinate here is 0.5 for the new one, and yet the x coordinate for the original one is what? 1. So that means the x coordinates were multiplied by a half. Maybe if I can use another one, okay, let's say we are using y, which is equal to let me use a trigonometric function here like sine. So that is what we are getting, okay? I want you to look at the period of this one. So it is 2 pi, okay? That is the angle it takes to repeat itself again. So every after 2 pi, you can see another one. This is 4 pi, okay? So that is the period. Its period is what? 2 pi. Now suppose we write y is equal to, then sine, where there is x, we put 2x. You see that? Now the period of this one is going to be pi, okay? You see from here to here. Then again, we can also see here, this is now the 2 pi. So it has repeated itself. Now, the first one, its period is 2 pi. And then the second one, its period is what? Pi. That means they divided, because these are even x coordinates, so they divided it by 2. So that means if we have y, which is equal to f of x, and then you get y is equal to f of ax, then this simply implies that you're going to have a stretch by factor 1 over a. Because we have seen the x coordinates, the stretch factor in here is going to be 1 over a. So you get this one and you divide it by 2. So the 2 that is here now is a half. So do you see that a half times the 2 pi is the one that gives you the pi that we are having here, which becomes the period of this new transformed curve? So what does this one mean? This one means that when we go back here, if I say now we are supposed to stretch by factor a third parallel to x-axis. So we shall have y, which is equal to f of now 3x. Do you see that? A 1 over 3. So it is coming from y is equal to f3 of x. So remember, when you are popping this one out from here, now it is going to become a fraction. So implying we shall have y, which is equal to 5. Then where there is x, you put 3x here. Then sine of 2. And then where there is x, you put 3x. And then finally, you get your answer as y, which is equal to 15x. Then minus sine of 6x. This is the equation of the transformed curve. And that is that. Question 3. The equation of the curve is this one. The following points lie on the curve. Non-exact values are rounded to 4 decimal places. We are given these points here. Then part A, find k, giving you answer to 4 decimal places. Okay. Now, if a point lies on the curve, that means its coordinates must satisfy the equation of the curve. Okay. So if I have this a here, which is 2k, that means the y coordinate is k, and then the x coordinate has to be 2. So I'll just substitute in here, and we say that for y, which is equal to x minus 3, then the square root of x plus 1, then plus the 3 here. That means k is going to be equal to, wherever there is x, we are going to put what? A 2. 2 minus 3, then the square root of a 2 plus 1, and then plus the 3. Okay. Then, of course, this one is a negative 1, then root of 3, and then we shall add on a 3. And they said we give our answer to 4 decimal places. That means k is going to be equal to what? 3 minus the square root of 3. This one will give us 1.2679. Answer? 1.2679. 4 decimal places. Now, since this is the degree of accuracy, if you put any other degree, you're going to be marked wrong. Okay? Like, for example, you put 3 significant figures, you'll be marked wrong. And yet, this one has only one word? Mark. So please always follow the instructions. Okay? Okay, so that is that. Then next, part B, find the gradient of AE, giving you answer to 4 decimal places. We know that gradient is the change in y over change in what? In x. Not so. Change in y over change in x. Now, what is the change in y? Look at A and E. So we have a 3 here. Then minus the k. Not so. Which k we have gotten as this. I'm going to use this one, not this one that is rounded off. Okay. Let me use the exact value. So minus, this is 3 minus root of 3. That is our k. Then we divide by the change in x, so that is 3, then minus 2, which is a 1, not so? And then when you open brackets, you will get 3 minus 3, that one goes, then a negative, and a negative, it becomes a positive, then your answer becomes a 3. So if they had asked for the exact value, then it would be root of 3. But then they want to 4 decimal places. What is root of 3? Is it 1.7321, something like that? Root of 3. This one is 1.73205, whatever, but to 4 decimal places, it will be 1.7321, 1.7321, 4 decimal places. Okay, we also follow the what? The instructions. They told us 4 decimal places, they have to be 4. Then next, they are saying that the gradients of BE, CE, DE, rounded to 4 decimal places are these ones here, respectively. And part C, state giving a reason for your answer, what the values of the 4 gradients suggest about the gradient of the curve at the point E. Okay, now what do we have here? At point E, the curve tends to a 2, not so? The gradient of the curve tends to a 2, because you can see it is moving 1.97, 1.99, 1.997, not so? You are moving from A then to E. So the gradient tends to a 2. So I will just say at point E, okay, the gradient of the curve tends to the 2. Okay, and they are saying, giving a reason for your answer. Then I can say this is because the gradient at E, is the limit of the gradients of the chords as x tends to 3, okay, or as delta x tends to 0. So what do I mean here? We are having our curve, let's say this is the curve here, okay? I'm just assuming this is the curve, and you're having, this is A, this point A. So here we are having our A is 2K, that is 1.2679, okay, 2, then K, and then there is point E here. Point E, you can see that its x coordinate is 3, 3, 3, and then the y coordinate is also 3. Now we are having these codes A to E. Which other points, by the way, do we have? We have D, C, and B. D, C, and B. So there is, maybe this is B, then C, then D, and then E. So there are these codes here. These codes here. Our K, what is our K? Is Y increasing? Yes, it is increasing. Okay. Very perfect. So we go like that, then like that. That one there, and then we also drew to this one here. So we are looking at, remember, every time you get the change, I mean the gradient, you are taking a change in y over the change in x, not so? The same thing. And then, so that's something with all of these points. So what we are going to do is we are going to keep on shifting this what? These points. So you see this line here, A to E. Let me even use red. This line here, A to E. So there is a change in X here that we can see. There's a change in X here, okay? Delta X. But then I can keep on changing this line here like this. So I put it here, put it here, put it here. By the time it comes to E, that means the change in X has gone. Do you see that? The change in X has gone. When this code was there to A, there was a change in X. When I brought it to B, the change in X was reducing. It was reducing on C. It was reducing at D. Then here it becomes completely zero. So that means, that is why I said that this is because the gradient at E is the limit of the gradients of the codes, these codes we are doing, like A to E, A to B, A to C, A to D. As X tends to 3, the X coordinate here is a 3, the X coordinate here is a 2. Remember, the X coordinates are increasing. When you look at this one is a 2, then 2.9, 2.99, 2.999, and then it comes to, so as the X coordinate tends to a 3, then the gradient tends to a 2, okay? Because you are also seeing, actually we found our gradient here. They told us to find gradient AE, 1.73, this whole big one here, you see? So by the time you move this code to E, then that line actually becomes a tangent at that point, okay? And by the way, if you maybe get this equation here and then you differentiate it, when you differentiate this one here and then you substitute X is equal to what? To 3, you will automatically get a 2, okay? That will be the gradient of that curve at that point, you see? So, but because this is a product of two algebraic functions, here you are going to use the product rule. And if you haven't peeped through A level, you don't know how to differentiate this one here, you see? And you're not supposed to use any differentiation anyway. So you just deduce, and they don't give a lot of marks for this. The maximum they can give you is 2. So that is that. Question 4 is coming from binomial expansions. The coefficient of x in this expansion is p, and the coefficient of 1 over x in this expansion here is q. Given that p is equal to 6q, find the values of k. Now, we know that from binomial expansions, if we have a plus b, which is powered by n here, we can have n combination 0, then a power n, and then b power 0. The power of the b is the one that comes into the combination here. So we have n combination 1, then a keeps on reducing in the powers, and then b keeps on increasing in the power, okay? So n 2, then we have a n minus 2, and then b will be to the power of 2. So you see this number, the same as the one down there. Then this one continues until we have the power of a is a 0. That is for the positive integer n, okay? Because if we have this n here, when it is not a positive integer, when it is a negative, such series do not end, okay? And those ones you cover them in A level. So if I want the term, then it is n combination the power of that second term, and also this one here. So for this one here, 4x then plus 10 out of x, then to the power of 3, we need the term in x, okay? So the term in x, we shall have 3 combination something, then our a here is this 4x here, then our b is going to be 10 over x. Now these powers, remember, a keeps on reducing in the powers, and then b keeps on increasing in the powers. So since this one is a 3, that means 4x will begin with 3, then 2, then 1, then 0. And then 10 over x will begin with the power of 0, then 1, then 2, then 3. So we are supposed to look at a pair such that when I put the pairs here, I'm going to remain with an x. Okay, the term is going to end in what? In x. If I put 3 and 0, you put 3 here and 0, x will be to the power of 3 here. It will end in that. So that means that one is not the one. If I put 2, 1, you put a 2 here and then you put a 1 here. This will be x squared over x. This one will give us x. So that means I'm going to choose this pair here, 2 and 1. So I will put here and then here. Then the power of this 10 over x is the one that comes into the combination here. So 3 combination 1, we get a 3. Then 4 squared, that is a 16. Then x squared, then times 10 over x. And that means here we are going to have 3 times 16, isn't that 48? Then 48 times 10, that will be 480, then x. Okay, so this simply implies that p is equal to 480, because they said the coefficient of x in this expansion is p, and the coefficient of x here is 480. Okay, then we go to this other one here for which one? We are given also this one here, 2x then plus k out of x squared then to the power of 5. Then which term shall we need? Term in 1 over x. So we have 1 over x. And here our n is 5. So we shall have 5 combination something. The terms we are having are 2x and then k over x squared. Okay, x squared. Now here the 2x is going to begin with the power of 5, then 4, 3, 2, 1, 0, and then this k over x squared will start from a 0, 1, 2, 3, 4, and 5. So we are supposed to also pick a pair. If I put 5 here and 0, it will end in x power 5. Okay, if I put 4 and 1, we shall have x power 4 and then x power 2 here. This one will end in x power 2, not so? So that means this one is also not giving us. Then we shall go to 3 and 2, and we see if this is 3 and then this is 2, then we can get x power 3. Then down here it will be x power 4, because this one will multiply with this, right? And then this one will be 1 over x, which is giving us what we want. You see that? So meaning I'll pick my powers using this one here, the pair 3 and then 2. Then the power here is the one that I'm going to put down here, and then we shall get a 2. So 5 combination 2 is the same as 5 times 4, that is 20, then divide by 2, that one will be 10. Okay, then times 2 power 8, power 3 will give us 8, then x cubed, and then times k squared, then out of x power 4. So meaning we shall have here 80, then k squared, that will be the coefficient of 1 over x. Okay, then, and they said here that the coefficient of 1 over x in this expansion is what? Is q. So meaning q, so q is equal to 80 k what? Squared here. But they also said here that given that p is equal to 6q, then find the possible values of k. So I'm going to get, remember they said p is equal to 6q. Our p is 480, then is equal to 6, and our q is 80, then k what? Squared, not so? Of course, this one is going to give you what? 6 times 8, that is 48. So you have 480, and also this one is 480 k squared. So when you divide all through by 480, don't you get 1? So meaning your k is going to be the square root of 1, but this one has to be plus or minus. So therefore k will be plus or minus 1. And remember, they said possible values, not so? So it is not one value. So that is that. Question 5. The function f is defined by this, for which x is greater than or equal to 0. Then part A, find and simplify an expression for f of x. That means you put f into the f. You compose f into the f. So f of x then is going to be equal to 2. Wherever there is x, I'm going to put f of x. You see that? Then you square it, then plus the 3. So what is our f of x? It is given as this. So I will say 2x squared plus 3. Then you square and then plus the 3. Let us first expand here. We are going to have a square here. That will be 4x to the power of 4. Then 2 times 2x squared times 3. That one will give us 4 times 3, that is 12, then x squared, and then square the 3. That one gives us a 9, then plus 3. Now multiply out the brackets. 2 times 4, that one will give us 8, x to the power of 4, and then plus 2 times 12, that one will give us 24, x squared, then 2 times 9, that is 18, and then plus the 3 here. So altogether, this one becomes 8x to the power of 4, then plus 24, x squared, then plus 21. And that becomes our answer here. Remember, they said we simplify. Okay, so this is the simplified one. Then part B, they are saying solve this equation here. Right from here, I'm going to get this one here, which is 8 x power 4, then plus 24 x squared plus 21, then I will equate to 34 x squared plus 19. Then bring everything this side, and then you get a quadratic in x squared. So this is 8 x power 4. Now 24 minus 34 will be negative 10 of x squared. And then 21 minus 19, isn't that a 2? It is equal to 0. Then I can divide all through by 2. Not so. I can divide all through by 2 such that we get a simplified quadratic equation. So this one is x squared squared. Not so. There's something I want to show you here. This is x squared squared. Then this will be 5, then x squared, and then plus 1, which is equal to 0. This is a quadratic equation in x squared. So let's see whether this one is factorizable using a calculator. You go to mod, then equations 5, and then we put 3 for quadratic. Our a is going to be the 4, then our b is going to be the minus 5, and then the constant part is a 1. So this one gives us 1 and then a quarter. So I would skip space, and then I write x is equal to a quarter. Actually, it is x squared because it is a quadratic in 1, x squared. And then x is equal to 1, mean x squared. Then you need to show the examiner the attempt to solve the quadratic equation. Okay, so give us a factor from which these roots are coming. So cross multiply, and then you get 4x squared. And then bring the 1 here. That one will be a minus. You see that? Then bring this one here. You get this other factor as x squared minus 1, which is equal to 0. By doing so, you have cheated the examiner. You have shown him the attempt to solve the quadratic equation. And then after here, of course, we are supposed to get our x values. So it will be plus or minus the square root of a quarter. And also here, x will be plus or minus the square root of 1. Now, looking up here, the x values in the f are supposed to be greater or equal to 0. So that means what we are getting here must be positive values. Okay, so this simply implies that x is going to be equal to square root of a quarter is a half, and then the square root of 1 is 1. So these are our answers. If you leave your answer here, plus or minus, you're going to get it wrong. Okay, that is that. Question 6 is coming from coordinate geometry. Points A and B have these coordinates, and the equation of the perpendicular bisector AB is this one here. Find the values of P and Q. Now, we know that a perpendicular bisector passes through the midpoint of a line segment. Okay, if this is the perpendicular bisector here, then this has to be the midpoint. Okay, let me even put it here. A perpendicular bisector passes through the midpoint of a line segment. Now, for A, which is H3, and then B, which is PQ, then we need to get its the midpoint. So the midpoint here is going to be, you get the average of the x coordinates, that is H plus P over 2, and then the average of the y coordinates, we are having 3 plus Q out of 2. Okay, and we know that for perpendicular lines, M1 is equal to M2. For perpendicular lines, M1 times M2, the product of their gradients is always equal to negative what? 1. Now, gradient of, what do we have? Gradient of the line AB. Now, what I'm going to do, since we said that perpendicular bisector passes through the midpoint, let me actually first leave this one out. Let me put it down here. Okay. For a point to be on a line, that means its coordinates must satisfy the equation of that line. Are we there? So we are going to have, this is the equation of the perpendicular bisector. So the y coordinate is this one here. That means we are going to have 3 plus Q out of 2, then is equal to, this is negative 2, the x coordinate is 8, then plus P out of 2, and then plus the 4. So from here we can get an equation in x and y, okay? In P and Q. So right from here, I can have 3 plus Q out of 2, and then here, this 2 will cancel with this one, then I will have negative 8, then minus P, and then plus the 4. Then I can multiply everywhere by 2 to eliminate this denominator, right? So we shall have here 3 plus Q, then this one will be equal to, this is negative 8 plus 4, that will be negative what? 4, then times 2, you get negative 8, then minus the 2P. So if I, let's say, take this one this side, that means Q is going to be equal to negative 8 minus 3, then that negative 11, then minus 2P. That is my equation 1. Okay, I keep it. Then I need to also get the gradient of now AB. Okay, the gradient of AB is going to be equal to, what are the coordinates of B and A? So we have change in Y, that is Q minus 3 out of P, then minus 8. But then this one is going to be equal to negative 1 out of the gradient of the perpendicular bisector, which is negative 2. Not so. Remember, when you get the gradient of this line here, then times the gradient of the perpendicular bisector, you get a negative 1. You see that? So that means the gradient of AB, which I can call maybe M1, then will be negative 1 divided by the M2, which M2 you have as negative 1, 2. So this one can help you to get the next equation in terms of P and what? And Q. Now this one will be positive a half, right? So if we cross multiply from here, we can have Q minus 3 is going to be equal to a half times the P. That will be a half of P. And then a half times negative 8. That one will be negative 4. So meaning Q from here is going to be a half of P. Then if this one comes this side, we shall have negative 4 plus 3, which will be negative 1, not so. So we shall put minus 1. And this one here is giving me the second one equation. So because this is the second equation here, solving 1 and 2, I just equate them, not so. So let us equate them. We shall have a half of p minus 1, then is equal to this one here, which is negative 11 minus 2p. So bring the p this side, you'll have 2, then plus a half, that will be 2.5, which is the same as 5p over 2. Then this one will be equal to, take this one this side, negative 11 plus 1, you'll get negative 10, not so. So if we cross multiply, this means that p is going to be equal to negative 10 times 2. Then after we shall divide by 5. So 5 goes into 10 2 times, so negative 2 times 2. Then p becomes a negative what? 4. And then what will be q? I can substitute in any of them. I can use this one, I can use this one. Okay, so suppose we use this one here. We shall have a half of negative 4. That will be a negative 2 minus 1. Then it becomes a negative 3. So therefore q is equal to negative 3.